Hi folks, we are back with the sixth sub question of this exercise 6.5 question number 3, where we are trying to find the local maxima minima points, and we are also looking out for their maximum and minimum values. So that's what we will be doing right now over here. So this is a function, as we did some trigonometric functions and so on in the question. So right now we will be doing this polynomial function. So let's check how the polynomial function comes up. Like we are having g of x, the function given to us is x over 2 plus 2 over x, but they give us a condition that x is positive. So they kind of give you the domain. So let us see now how we can work with this. As we do always, let's take the first derivative, let's take the second derivative and get the critical points and so on. So the first derivative, it's going to be g dash x. Half times x you can treat it. So half times x derivative will be 1. And this is like writing 2 times x raised to minus 1 if you want. So when you take the derivative, it will be 2 times minus 1 x raised to minus 2 when you take the derivative n x raised to n minus 1. So when we restructure it, it will be half plus, or rather minus 2 over x square over. If you want to write it, you could write it like that. Since we require the second derivative also, let's look at the second derivative. This part will be 0 because it's a constant, no more you can get a derivative. And here the derivative is 2 times minus 2 times x raised to minus 2. So that will be minus 2 times n x raised to n minus 1. So that will come to minus 2 times x raised to minus 3 when we do the restructuring. So this will come to 4 times x raised to minus 3, or 4 over x cube. So this is our first and second derivative. Now as usual, let's get the critical point. So for that we will make g dash x equal to 0, or the first derivative equal to 0. Let's check how it comes. So what we'll get, we will get half minus 2 over x squared equal to 0. Let's solve this. So this will come to 2 over x squared becoming half, or when we solve it further, maybe we can take the x square on the other side. So you will get x square on the other side, 2 will go the other side, so 2 times 2 it's 4. So you get the value of x as plus or minus 2. So the x can take, the critical points can be both 2 and minus 2. But there is a problem here. We cannot take both these values. Plus 2 and minus 2, both we cannot take these values. Why? Because they have told us the domain is x greater than 0. So we don't have to take the negative value at all. So we have to only consider x equal to 2. So that is going to be our alone value that we have to consider. So therefore x equal to 2 is the only possible value, because the domain is like that, is the only possible value. If you want, you can write, since x is always positive, so we are going to take that value. So we need to do the checking for that itself. So let's see whether it's a maxima point or a minima point. For that we take the second derivative and check what happens to 2 at the second derivative. So when we happen to substitute that, we will get 4 times 2 raised to minus 3, which is 4 over 2 cube, that's 8. You get the answer as half, which is positive. So therefore your x equal to 2, therefore 2 is a minima point. Yeah, it's a point of minimum. Because it's a minima point, automatically we have to find the minimum value also. So let's find the minimum value, g at 2. Let's find what it is. It is 2 over 2 plus 2 over 2 again. Yeah, both are 2's. 2 over 2 plus 2 over 2. So that's 1 plus 1, which comes to 2. So you're getting the minimum value as 2. So g of 2, you will get it as 2. It's a simple problem. Only thing, you have to be a little careful when you take the derivative, since negative exponents are coming for the first time. So that's how it is. You're getting the minimum value g at 2 as 2. Yeah, we don't have the other one. Yeah, that should be all for this video. There are problems more. There are more problems in this question that we will be taking up in the upcoming videos. So all of you, as usual, please share popularize the channel, share the videos, and spread a word. Thank you.